In part 1 of lecture 2, we will discuss the role of the operating system. An operating system is a program that controls the execution of application programs and acts as an interface between applications and the computer hardware. It can be thought of as having three objectives. Convenience. An operating system makes a computer more convenient to use. Efficiency. An operating system allows the computer system resources to be used in an efficient manner. Ability to evolve. An operating system should be constructed in such a way as to permit the effective development, testing, and introduction of new system functions without interfering with service. The hardware and software used in providing applications to a user can be viewed in a layered or hierarchical fashion, as depicted in the figure. The user of those applications, the end user, generally is not concerned with the details of computer hardware. Thus, the end user views a computer system in terms of a set of applications. An application can be expressed in a programming language and is developed by an application programmer. If one were to develop an application program as a set of machine instructions that is completely responsible for controlling the computer hardware, one would be faced with an overwhelmingly complex undertaking. To ease this chore, a set of system programs is provided. Some of these programs are referred to as utilities or library programs. These implement frequently used functions that assist in program creation, the management of files, and the control of I/O devices. A programmer will make use of these facilities in developing an application, and the application, while it is running, will invoke the utilities to perform certain functions. The most important collection of system programs comprises the operating system. The operating system masks the details of the hardware from the programmer and provides the programmer with a convenient interface for using the system. It acts as mediator, making it easier for the programmer and for application programs to access and use those facilities and services. Briefly, the operating system typically provides services in the following areas. Program development. The operating system provides a variety of facilities and services, such as editors and debuggers, to assist the programmer in creating programs. Typically, these services are in the form of utility programs that, while not strictly part of the core of the operating system, are supplied with the operating system and are referred to as application program development tools. Program execution. A number of steps need to be performed to execute a program. Instructions and data must be loaded into main memory, I/O devices and files must be initialized, and other resources must be prepared. The operating system handles these scheduled duties for the user. Access to input-output devices. Each I/O device requires its own peculiar set of instructions or control signals for operation. The operating system provides a uniform interface that hides these details so that programmers can access such devices using simple reads and writes. Controlled access to files. For file access, the operating system must reflect a detailed understanding of not only the nature of the I/O device, for example, disk drive or tape drive, but also the structure of the data contained in the files on the storage medium. In the case of a system with multiple users, the operating system may provide protection mechanisms to control access to the files. System access. For shared or public systems, the operating system controls access to the system as a whole and to specific system resources. The access function must provide protection of resources and data from unauthorized users and must resolve conflicts for resource contention, detection, and response. A variety of errors can occur while the computer system is running. These include internal and external hardware errors, such as a memory error or a device failure or malfunction, and various software errors, such as division by zero, attempt to access a forbidden memory location, and inability of the operating system to grant the request of an application. In each case, the operating system must provide a response that clears the error condition with the least impact on running applications. The response may range from ending the program that caused the error, to retrying the operation, to simply reporting the error to the operation. Accounting. A good operating system will collect usage statistics for various resources and monitor performance parameters such as response time. On any system, this information is useful in anticipating the need for future enhancements and in tuning the system to improve performance. On a multi-user system, this information can be used for billing purposes. There are three key interfaces in a typical computer system. The Instruction Set Architecture, or ISA. The ISA defines the repertoire of machine language instructions that a computer can follow. This interface is the boundary between hardware and software. Note that both application programs and utilities may access the ISA directly. For these programs, a subset of the instruction repertoire is available, that is, the user ISA. The operating system has access to additional machine language instructions that deal with managing systems resources, that is, the system ISA. Application Binary Interface, or ABI. The ABI defines a standard for binary portability across programs. The ABI defines the system call interface to the operating system and the hardware resources and services available in a system through the user ISA. The Application Programming Interface, or API. The API gives a program access to the hardware resources and services available in a system through the user ISA supplemented with high-level language library calls. Any system calls are usually performed through libraries. Using an API enables application software to be ported easily through recompilation to other systems that support the same API. The operating system is responsible for controlling the use of a computer's resources, such as input-output, main and secondary memory, and processor execution time. But this control is exercised in a curious way. Normally, we think of a control mechanism as something external to that which is controlled, or at least as something that is a distinct and separate part of that which is controlled. For example, a residential heating system is controlled by a thermostat, which is separate from the heat generation and heat distribution apparatus. The operating system as a control mechanism is unusual in two respects. The operating system functions in the same way as ordinary computer software. That is, it is a program or suite of programs executed by the processor. The operating system freely relinquishes control and must depend on the processor to allow it to regain control. Like other computer programs, the operating system provides instructions for the processor. The key difference is in the intent of the program. The operating system directs the processor in the use of other system resources and in the timing of its execution of other programs. But in order for the processor to do any of these things, it must cease executing the operating system program and execute other programs. Thus, the operating system relinquishes control for the processor to do some, quote, useful, unquote, work, and then resumes control long enough to prepare the processor to do the next piece of work. The mechanisms involved in all this should become clear as the lecture proceeds. The figure in the slide suggests the main resources that are managed by the operating system. A portion of the operating system is in main memory. This includes the kernel or nucleus, which contains the most frequently used functions in the operating system, and, at a given time, other portions of the operating system currently in use. The remainder of main memory contains user programs and data. The memory management hardware in the processor and the operating system jointly control the allocation of main memory, as we shall see. The operating system decides when an I/O device can be used by a programming process and controls access to and use of files. The processor itself is a resource, and the operating system must determine how much processor time is to be devoted to the execution of a particular user program.